There will be times when you have to find the average value of a function on an interval. And this is really useful because if you're taking a road trip and you're going 60 miles per hour, let's say that you go for 2 hours, the integral from 0 to 2 of 60 dx is telling us to calculate the area under the curve, and because this is a rectangle, we know that we went 120 miles. Because, basically, if you take miles per hour times hour, they cancel and you get miles. So, if I asked you what the average speed in this situation, what it was, well, it was 60 the whole time, so that must be the average. Now, there are going to be other curves that kind of have an average of 60, but they're not going to be exactly 60 the whole time. If I were to draw a dotted line here, that's kind of the average. But if you imagine that you are able to find all the area under this curve, and if you were to imagine all this area flattening kind of down, almost as if this was water and it was filling this container right here, it would level off at 60 right here. And so to find the average, you're still going to be doing an integral of f of x from 0 to 2 dx. That'll find the entire area here, but you're going to divide by the interval that you are interested in to figure out the area. The average value, So the integral from 0 to 2 of f of x is that area, and then if we divide by the interval, we're going to get the average, which is 60 here. So another way to say it is, there's all this area that we're figuring out under this curve right here. And if you were to create a perfect box of the same width, a width of 2, what would the height of it be? And then it would look like this over here. So, let's do an example maybe to figure out exactly what this would mean in certain circumstances. Like if f of x is x squared, and we're going from 1 to 3. Alright, so we have a picture of x squared like this, and we're going from 1 to 3. Now if you were to guess, I'm guessing the average value would be somewhere like right there, and it's hard to tell exactly what that would be. So what we'll do here is we will figure out the area all under this curve and divide by the width being 2. Alright, so we integrate from 1 to 3 of x squared dx. Now this is going to be the same as which you could write as 1/3 x cubed. A lot of people will just write it like this, saying we plug 3 in, we plug 1 in. So this will be 27 thirds minus 1/3, which is 28 thirds. Or you might say 9 1/3. Either way, and then that is the area under this. But if you were to think about flattening this out so that it was a rectangle of the same width, the average value would be the height here. Or you take 28 thirds and you divide by the width of the box, which is 3 minus 1, or 2. So 28 thirds divided by 2 is 28 sixths. And if we simplify it, it's 14 thirds, or 4 2/3. So over this, we range from 1 to 9, but at about a height of 4 2/3, that is the average value overall. Let's do another one here, because you're not always going to do a proper integral. Say, for example, you needed to go from 0 to 2 of the square root of 4 minus x squared dx. Well, we haven't figured out how to do an integral like that yet. What we can do, though, is picture that this is actually a quarter of a circle going from 0 to 2. Now, find the average value of the square root of 4 minus x squared over 0 to 2. What we would do is we would figure this out and then divide by the interval width, which is 2. So first of all, in this case, the radius is 2. I think about a circle, and I plug 2 in to get 4 pi. But because this is 1/4 of the circle, this area right here is going to be pi. Alright, now to find the average value, or the average height, visually it'd be like right about here maybe. What we would do then is we would take the integral that we just found out, 4 minus x squared dx, and we would divide by 2 minus 0, which is the width of our interval. So really, this integral we found out to be pi, and this width is 2. So the average height of this function is going to be pi over 2 on 0, 2. Okay, and so one more quick one. In this case, we could do this with integrals or by just finding the area. Because when you graph y equals x, it looks like this, from 0 to 5. Okay. Now, the idea is that the average value is when you take all of this and you level it off. In this case, there's an equal amount of area above and below, so the average value should be 2.5. Okay, so we're going to write this in mathematical notation. And then we divide by the interval width. Now, let's actually figure this out mathematically. That would be 1/2 x squared from 5 to 0, and we're just keeping 5 minus 0 there. If I plug this in, it'd be 25 over 2 minus 0 over 2 all over 5 minus 0. So that's the area. This is the width of the interval. Now, this is just going to be 25 halves divided by 5, which turns out to be 25 divided by 10. And yep, it turns out to be 2.5. So this example might be easier to follow because it spends the same amount of time above and below that spot. And so this is your average value.